Hello, my name is Valerie and I'm an undergraduate student at the University of Guelph in Guelph, Ontario, and I worked on this project with my supervisor, Claudia Wagner-Riddle, as well as Shannon and Steve Sargent. And the purpose of this study was to compare different instruments that are currently used to measure gas fluxes, specifically carbon dioxide, as well as two different processing packages that are available to process Eddy covariance data. We had three different instruments set up over a cornfield in southern Ontario. The first two were two closed path analyzers, a EC155 from Campbell Scientific and a trace gas analyzer 100A also from Campbell Scientific, and they were mounted on one tower. And then approximately 700 meters away we had an open path sensor from Lycor, the LI7500, that was mounted on another tower. We used two different processing softwares. The first was Eddy Pro, which is a software that's freely available online from Lycor, and the second one is TK3, which is also freely available online. Both have been used in published literature studies, and we just wanted to determine which would make the most sense to use in our lab, and also if there are any major differences between the two of them and between the different instruments as well. So after the data had been collected, we used approximately a 1 month period of data in the middle of the growing season, so from June 24th to July 21st. After it had been collected, it was processed through both software packages to try and get half-hour CO2 fluxes and U-star values, which we used to compare different instruments and different software packages. In the software packages, it was despiked, and corrections were applied wherever was applicable for the instruments. Wherever possible, the same corrections were used between software packages. Where it wasn't possible, the same phenomena were corrected for using different corrections. After the data had been corrected, it was filtered. So anytime where the instruments weren't working, where the software packages had flagged the value, where there was somebody working in the field or someone working on the instrument, those times were taken out and weren't used in the comparisons. After that, the data was compared using paired t-tests, so anytime where there was a value from the same instrument being processed with different software packages, or different instruments being processed within the same software package at the same time period, those values went through a series of paired t-tests, and we also ran a linear regression. The findings from that were that between the EC155 and the trace gas analyzer, there was almost a one-to-one relationship between the half-hourly CO2 fluxes. This is great because they were measuring the same air, they're mounted on the same tower. It's great to see that they had a higher squared value because it means that the instruments are both giving you the same thing. So if you're communicating to a scientist who's using a different instrument, assuming they both are set up properly, it's easier to compare those fluxes because you know that there's less of the variation due to the instrument and more as it is due to the variation that's actually happening in the environment. When the trace gas analyzer 100A and the EC155 were compared to the Lycor sensor, they did show a close to 1-to-1 relationship, but the data was noisier and didn't have quite as a high R-squared value. The R-squareds were in the range of about 0.6, whereas the R-squared for the relationship between the EC155 and the trace gas analyzer was about 0.8, which is much higher correlation. When the software packages were compared using the U-star values for the friction velocity, we found that there was no significant difference between the U-star value that the TK3 software gave and the software that the U-star value that the Eddy Pro software gave for the trace gas analyzer and the EC155. However, there was a small difference that was statistically significant between the Eddy Pro output and the TK3 output for the open path Lycor sensor. Overall, our conclusions were that the Eddy Pro software is definitely much easier to use and has a clear output and better documentation, although the original intention of this study had been to also compare the CO2 fluxes between instruments. The TK3 fluxes we found were not as easily readable and weren't giving values that were reasonable, and so they weren't used in this analysis, and that was something for future work. However, the TK3 definitely shows potential, but Eddy Pro, there's a much clearer cause or effect and much more feedback given to the user, so when you put in something wrong, you get a feedback message telling you what you did wrong and what you probably should do to fix it. Whereas with with TK3, it usually just crashed, and so that made it a little bit difficult to determine what you're doing wrong or how to fix it. As far as the instrument comparison goes, we found that the EC155 and the trace gas analyzer showed a strong correlation to each other, which makes sense. They were mounted on the same tower. However, when they were compared to an instrument that was mounted on a different tower, there was a little bit more variation, and the only way we would be able to determine if this variation was because of the instrument or because of spatial heterogeneity of the field would be to move them all to the same tower. And so that would be something we can look to do in the future. And I look forward to answering any of your questions. Thank you very much.